This rock could be worth millions, but right now, it looks like nothing. No shine, no glitter, just dull, dusty stone you'd walk past without a second glance. Yet, hidden inside this unremarkable piece of earth is one of the most coveted metals in human history: gold. But here's the thing most people never realize: gold doesn't start out precious. It doesn't emerge in the ground as gleaming bars or elegant jewelry. It begins its life trapped, invisible, locked inside layers of rock and dirt. The transformation from worthless rubble to priceless metal is a brutal, methodical, and utterly fascinating process, one that blends chemistry, engineering, and fire. What you're about to witness isn't magic. It's science, and it's far more dramatic than you'd ever expect. To understand how gold becomes priceless, we first need to see where it actually comes from. Forget everything you've seen in the movies. There are no riverbanks lined with golden nuggets, no caves overflowing with treasure. In reality, gold is one of nature's best-kept secrets, microscopic, scattered, and buried deep within the earth. Gold exists in trace amounts, often just a few grams per ton of rock. It hides inside quartz veins, sulfide ores, and ancient sedimentary layers formed millions of years ago. Sometimes, it's so finely dispersed that you'd need a microscope to even see it. To put this in perspective, mining operations can process thousands of tons of rock just to extract a single ounce of gold. That's why gold mining isn't a treasure hunt. It's industrial warfare against geology. Massive drills penetrate deep underground. Explosives shatter mountainsides. And every fragment of rock is carefully analyzed to determine if it's worth processing, because once that ore is hauled to the surface, the real battle begins. Once this ore is pulled from the earth, the real work begins inside the refinery. Inside the refinery, the roar is deafening. Conveyor belts rumble under the weight of tons of ore. Dust fills the air. And at the center of it all, colossal machines go to work. The first step is simple, but brutal. Crush the rock into oblivion. Jaw crushers clamp down with thousands of pounds of pressure, breaking boulders into gravel-sized chunks. Then, grinding mills, massive rotating drums filled with steel balls, pulverize those chunks into fine powder. The goal? Expose every microscopic particle of gold hidden inside. Why does size matter so much? Because gold doesn't just sit on the surface of the rock. It's embedded deep within the crystal structure. The finer the powder, the more surface area is exposed, and the easier it becomes to extract the gold chemically. This isn't delicate work. It's industrial domination. Noise, dust, and raw energy combine to reduce solid stone into something that looks like flour. But crushing the rock doesn't separate gold. Chemistry does. Now comes the moment where modern science meets ancient desire. The crushed ore is mixed with a carefully controlled chemical solution, often cyanide, though newer, safer alternatives are gaining ground. This isn't reckless dumping. It's precision chemistry. The solution is designed to do one thing: dissolve gold and only gold out of the rock. Here's how it works. Gold, despite its reputation for being inert, reacts with cyanide in the presence of oxygen. The metal binds to the cyanide molecules, forming a soluble compound that separates from the worthless rock around it. Think of it like a molecular kidnapping. The cyanide grabs the gold and pulls it into solution, leaving everything else behind. The mixture is stirred in massive leaching tanks for hours, sometimes days. The gold, now dissolved and invisible to the naked eye, floats in the liquid, while crushed rock settles to the bottom as waste or tailings. Of course, this process demands intense safety protocols. Cyanide is deadly in the wrong hands, so refineries use airtight systems, neutralization processes, and environmental monitoring to ensure nothing leaks into the surrounding ecosystem. Once dissolved, gold is invisible, but it hasn't disappeared. At this stage, gold is everywhere and nowhere. It's dissolved in thousands of gallons of liquid, chemically bound but impossible to see. So, how do you recover something invisible? The answer lies in adsorption and precipitation. One of the most common methods is carbon adsorption. Activated carbon, a highly porous material, is introduced into the gold-laden solution. Gold molecules latch onto the carbon like magnets, pulling themselves out of the liquid. The carbon is then filtered out, now loaded with concentrated gold. Alternatively, zinc powder can be added to the solution. Zinc is more reactive than gold, so it forces the gold to precipitate out as a solid. The result? A dark, muddy sludge that doesn't look remotely valuable, but it's packed with gold particles. This sludge is filtered, dried, and compressed. What emerges is a dense, brown concentrate that still contains impurities, silver, copper, traces of other metals. But the gold is finally in solid form again. It's an awkward, unglamorous stage, but it's a critical milestone. This gold still isn't pure. Refinement is only halfway done. Now, we enter the realm of fire. The gold concentrate is loaded into industrial furnaces, where temperatures soar past 1,000 degrees Celsius. At this heat, gold melts into a molten, glowing liquid. But it doesn't melt alone. Impurities melt too. To separate them, refiners add flux, a mixture of chemicals designed to bind with unwanted metals and minerals. As the furnace roars, the flux reacts with impurities, forming a layer of slag that floats to the surface. This slag is skimmed off, leaving behind pure molten gold beneath. The process is both violent and elegant. Flames roar. Molten metal glows like liquid sunlight. And when the furnace finally cools, what's left is a rough, heavy ingot called a door bar. Door bars are impressive, dense, golden, and unmistakably valuable. But they're not pure. They typically contain 85 to 95% gold, with traces of silver and other metals still mixed in. To the untrained eye, they look like the final product. But to a refiner, they're just the beginning of the final chapter. Door bars look impressive, but they're not yet 24K. To reach true purity, 99.99% gold or 24 karat, refiners turn to advanced techniques like electrolysis. Here's how it works. The door bar is suspended in an electrolyte solution and connected to an electrical current. As electricity flows, gold atoms are stripped from the bar and redeposited onto a pure gold cathode on the opposite side. Impurities fall away as sludge or remain on the original bar. It's slow, painstaking, and incredibly precise. But when it's done, the result is pure gold, chemically clean, standardized, and ready for certification. Why does purity matter this much? Because in global markets, trust is everything. Central banks, investors, and jewelers demand verifiable quality. A 24K gold bar isn't just metal. It's a financial instrument. Every bar must meet international standards, stamped with purity, weight, and serial numbers. This is the moment the transformation is complete, from invisible dust to certified treasure. Now the gold is pure, but it still needs to be shaped. Molten gold is poured into precision molds. Steam hisses. The metal cools, solidifies, and takes its final form, the iconic gold bar. Each bar is carefully stamped with critical information: purity level, weight, serial number, and the refinery's hallmark. These markings are more than decoration. They're a passport for global trade. Without them, the bar is worthless on the open market. After casting, each bar is weighed to the tenth of a gram. Any deviation triggers a recheck. Quality control is absolute. Bars are inspected for air pockets, impurities, and structural integrity. Finally, they're logged, photographed, and cataloged. Some head to secure vaults. Others are shipped to central banks, jewelry manufacturers, or private investors. The journey from rock to bar is complete. These bars don't just sit in factories. They shape global finance. Gold doesn't rust. It doesn't corrode. And it never loses its identity. That's why, for thousands of years, civilizations have trusted it as the ultimate store of value. Central banks hoard it. Investors flee to it during crises. Entire economies rise and fall on its price. Unlike paper currency, gold can't be printed into oblivion. Unlike digital assets, it doesn't rely on networks or electricity. It just is tangible, timeless, and universally recognized. Even in the age of blockchain and AI, gold remains a bedrock of financial security. Countries stockpile it, markets track it, and in moments of uncertainty, people turn to it. Because at the end of the day, gold is more than metal. It's trust condensed into 400-ounce bars. And it all started with a rock that looked completely worthless. Let's rewind for a moment. A dull, dusty rock, crushed into powder, dissolved into liquid, burned in fire, refined to perfection. And finally, cast into bars that hold the weight of nations. This is a hidden journey of gold, a process most people never see, but one that underpins trillions of dollars in global wealth. Every gleaming bar in a vault, every gold coin in a collection, every piece of jewelry is worn with pride. They all began the same way, as invisible particles locked inside stone, waiting to be freed. The transformation isn't magic. It's engineering, chemistry, and human ambition working in perfect harmony. And now, when you see gold, you'll never see it the same way again.